Hello, everyone. Thank you so much for joining us for today's webinar. I'm personally very, very excited about it. We have Nick Darkson. Did I say that right?
You got it.
One of those victories for the day with us. And he's from Sony KOOV, and he is going to teach you about how, sort of the basics of coding in the introductory program language, which will help anybody who's interested in getting it incorporated into their homeschool. So with that, I'm going to turn it over to Nick.
Great. Thank you so much, Kaylin. Let me get my screen share up and let me know when you can see it. Just give me 1 second here.
While he's doing that, I just realized I got so excited I forgot all of our housekeeping sort of things. Nick is going to present, and then at the end, we're going to do Q&A. So while he's going through the presentation, please put any questions you have in the chat box, and we will get to as many as we can as soon as we can.
Okay.
And now I mean it. It's all yours, Nick.
Great. And can you see my screen now?
Absolutely.
Great. It should be on that presentation deck. So great. Thank you so much for the introduction, Kaylin. Hi, everyone. It's very nice to see you today. Thanks for carving out some time. As Kaylin mentioned, my name is Nick. You are here for the Getting Started with Visual Programming webinar with Sony KOOV. Again, I'm Nick Jarkson. I'm a product marketing specialist with Sony Electronics. So thanks for joining. And with that, let's go ahead and get started. Give me 1 second just to get my controls going. Oh. 1 second, sorry, just some minor issues here. Come on. Okay, so for coding, so we're just going to start off with a little introduction of what coding is. For those who aren't familiar, coding is essentially giving step-by-step instructions to computers so that they can do something, complete some kind of task. These instructions can be internal instructions, like searching for a piece of information within the system, or it can be external tasks, like, for instance, on my computer, when I tap the J key, that would then prompt the computer to show the letter J in my Word document. So all this is done through code. We all interact with things that have been coded pretty much all day long, every day. It's the world that we live in. And essentially, once those coding instructions are written, they're then turned into a program that can be run on a computer. So that's kind of the process of how it goes. As you're all aware, and why you're probably here, is STEM education is huge, and especially coding. Coding, like I said, is something we interact with on a day-to-day basis, and having that general understanding of technology is becoming so important for students nowadays. And there is a big gap between, this is a subject that parents want students to learn, yet a lot of schools still aren't teaching it. So there is this room where parents and kids on their own have a lot of freedom and a lot of responsibility, unfortunately, to kind of self-teach themselves these amazing skills. So just like humans, there are thousands of languages out there in the world, and computers also speak in different programming language. There are thousands of different kinds of programming languages. Some are very particular and are used to accomplish a very certain or specific task, and some are a little more general. You all have probably heard of a few popular ones, maybe like Python or Java, JavaScript, C++. The point is that there are thousands of these languages out there. They're constantly evolving, and it can be really intimidating to get started and to think, okay, well, which one do I want to learn to begin with? And that's a really daunting task for someone to pick up. And that's kind of where visual programming comes in. So visual programming is essentially any programming language that lets users manipulate it through visual or graphic rather than textually. So you can see in these two examples here that I have on my screen that these are more graphic elements of code rather than just these huge walls of text that you might see if Maybe sometimes you've looked into the back end of like an HTML or something like that. So when it comes to visual programming, one of, if not the most popular visual programs is something called block-based programming. Block-based programming, again, much like all of these, it wears many hats, different faces, different names. You may have heard of drag and drop programming, or maybe you've heard of Scratch, which is probably the most popular block-based programming language, or maybe just you've heard block coding before. Essentially, these are all the same things. They all mean the same thing. And the really, really cool thing about block-based coding is it makes coding much more fun and approachable so that anyone can learn it at any age group. It's really, truly a tinkering kind of activity. So if you're a tinkerer at heart, I definitely am. Block-based coding is perfect for you because it's more of a learn as you do kind of thing, and it makes it feel much more like play rather than actual coding lessons. So I mentioned this earlier, but block-based coding really makes coding approachable, easy to access, easy to understand, and it provides that foundation for computer science, computational thinking through visuals rather than text. So here I have a side-by-side on my screen that you can see, and they essentially boil down to the same thing. So let's look at line 1 up here of our HTML. You can see this is our initiator, and then if you come over to the block-based screen, or the block-based image, they essentially follow a very same structure, right? Like if you drew lines around that written code or drew them into blocks, these would look very, very similar. And that's really the main point, is that the block-based programming, they have written code behind them, but they show up on your screen as these blocks. So you don't necessarily have to worry about proofreading individual text items. It really simplifies it so that students can focus more on concepts. So again, code is provided in blocks in visual format that the learner then can snap together to make their creation act. So instead of actually writing it out line after line after line, it's these blocks that you're snapping together. And you can see this on my image here. So it makes coding much more tangible to a beginner who maybe struggles to grasp that concept of what coding is. So it makes it a much more tangible and approachable experience. Using this image as an example, you can see, and my screen's off to my right here, so sorry if you see me drift in and out a little bit. The control, you can see there are these different blocks of code. We have our start, our function, we have wait functions and forever loops, and I'll get into these concepts more later in the presentation. Don't worry, we're just going to cover some basics right now. And this is a piece of code that I put together. So it has our start, our initiator, then it goes into something called a loop, a forever loop. Then you can see our first green block is actually going to turn our LED on. So it's telling the LED that's been plugged in to port V2, and I'll explain this again later. It's telling it, hey, this LED is plugged into this port V2. Let's turn that on, and then let's wait 1 second. And then that same LED in port V2, let's now turn that off and wait 1 second. So it's reading this line by line, start, then forever, LED on, wait, LED off, wait. And then as you get finished through that second, wait 1 second, you can see we're down at the bottom of our forever loop, which then would bring it back to the top. So this code that you're looking at is essentially going to make an LED blink on and off for 1 second forever until it runs out of battery or the light bulb needs changed. This code would continue to go on and on and on and on. So it's really cool way to kind of show code in a visual format. Block-based coding activities are perfect as a jumping in point. It's really fun. Anyone can learn to do it, learn to pick it up. It makes coding approachable, and it really lays that foundational understanding, which is what it's all about, right? With those thousands of written languages, pretty much everyone starts with block-based coding because it provides that foundation to get those concepts down, because those concepts are going to stay true no matter which coding language you go into after, whether it's HTML or Java or JavaScript. So again, it is that foundational learning. But the cool thing about block-based learning is it allows the students to use their imagination and get creative while still providing that intro to fundamental STEM concepts. So concepts like just plain old coding or computer science or algorithms and computational thinking, video game creation. I'll get into an awesome thing out there that is a video game creation app that uses block-based coding. Robotics is another one, and software engineering. So it is this awesome, awesome jumping in point for all things coding and all things STEM. Next one up. Excuse me. So block-based programming languages, they allow you to write code by snapping blocks together, like how I showed in my last example. So for this example, you can see there's 2 blocks of code here. There's a when start pressed block of code, and then there's a move blank steps block of code. So if I was looking at this image below it, and this is my little pal right here, and my goal is to get my computer pal over to his drink. He's thirsty, it's early, he wants his iced coffee, we all do. So what are the instructions that I have to give my little robot pal to make sure that he can get his coffee in the morning? Well, we need him to move. How many paces do we need him to move? We need him to move 3 paces. So we would go ahead into our block-based code here. We would have this move blank steps code block that we'd snap in, and then we'd click that bubble and we'd type 3. Now, if it was 4, we would type 4, and those are variables that you can include, but that's essentially what it boils down to. And there are so many programs and websites out there that support this kind of block-based learning or block-based coding. And the tools for other STEM elements are in there too. So if you're interested in robotics, you can combine coding with robotics or coding with something else. So it's not just a software thing. It can be used to expand into other STEM areas too, like design or video game programming, like I mentioned. So there's a lot of different things you can do with it. All right, so let's talk some resources out there. There are a lot of resources that provide access to block-based code lessons or code editors, many of which are free. So Scratch, I mentioned this earlier, this is probably the single most popular block-based program out there. It was developed by MIT. You can create video games or create sprites and really do cool creative things with coding in there, all while learning while you do it. Code.org is a website that is developed to encourage people to pursue computer science. So there are some cool coding things and block-based coding lessons and programs in there that you can poke around. Khan Academy kind of falls in that same area as code.org. It's really just an archive of resources for computer lessons or projects or all sorts of cool STEM ideas, many of which include block-based coding, obviously. And then KOOV is one of those things that combines another aspect with coding. So KOOV is a robotics and coding tool for foundational STEM. Essentially, you're coding on a computer screen, and then you're building robots with pieces, and then that code makes the robots move. So the main point here is, again, you can combine coding, you can have it as a standalone item, or you have the ability to kind of build upon it and build it out as well. So it is a really cool tool to let kids get creative with. Okay, so now that you know kind of what block-based coding is and what resources are out there, I do have some lessons that we're gonna walk through, so that way you're a little more familiar with the concepts. So again, the coolest thing or the most important thing about block-based coding is that it allows students to focus more clearly on concepts rather than spending all their time actually writing and even more so proofreading their code that you see with written languages. Some written code can be 100, 1,000, 100,000 lines long, and imagine how long it takes to proofread that. If you switch 2 letters in that code, then that code isn't going to work and you're going to have to go and find your errors. Whereas with blocks, those blocks are already functioning code pieces, so you know they're good to go. And so if something isn't happening, you know it's more of an order issue rather than, okay, where is my typo in this code, which is something that you experience often with other coding languages. So let's talk about 4 main concepts that every programmer or every coder should know. These 4 concepts you can find in any coding language, and they are loops and iterations, conditionals, functions, and lists. And we'll get into each of those in more detail right now. Okay, excuse me. Let's talk loops. So a loop is a set of steps that can be repeated. So that step is a loop. The specific step that's being repeated, if it's gone through once, that's an iteration through a loop. So since coding is providing that step-by-step instructions to complete a task, if you want a robot to repeat a step, you would need to build a loop into it. So building that step that can be repeated in that code is building a loop. And as that code passes through that loop once, that's one iteration. So I have some examples here on my screen. You can see that there's 3 steps here. There's open lid, eat cookie, close lid. The eat cookie step can be repeated. So that's our loop. And each time our robot friend eats a cookie, that's an iteration of that loop. So pretty straightforward concept, but again, this is something that comes up in all sorts of code all over, and we'll show you some actual examples as well after this. All right, on to the next one. Conditionals. We do these every day. These are making decisions. These are if-then statements. If I finish my homework, then I can play video games. If I go for a run this morning, then I can have a donut for breakfast. So computers need these to make decisions as well. And again, this is something that we interact with on a daily basis without you even knowing. So let's think of some examples for conditionals. If I type J on my keyboard, then the J will pop up on my Word document. If I approach the door and get within 5 feet, the sensor will sense my presence and it'll open the door. Then it'll open the door. If I leave a room and 30 minutes go by with no further motion detected, then the lights turn off. So that's automating everything, right? That's automation, automatic lights, automatic doors. These are all conditionals manifested in real life. You can also set up a conditional loop. So that is repeating if the condition is true. So for example, here, let's check to see if there are more cookies in our cookie jar. If there are more cookies, let's have another. If the jar is empty, let's close the lid. So that's a conditional loop that combines those 2 concepts of an if-then, and then also that repetition of a specific step. So now you know loops and iterations, you know conditionals. Let's move on to functions, which is, again, another key concept that you'll see in coding all the time. So for functions, you can think of functions essentially as a shortcut. So if we want to tell a robot to bake a cupcake, we need to crack some eggs, right? So let's come up with the steps required to crack an egg. First, remove egg from carton. 2, crack eggshell on the bowl. 3, open the eggshell. And 4, let the egg come out. So that is 4 steps to crack 1 egg. Now let's imagine that the recipe calls for 100 eggs. Well, now that's 4 times 100. That's 400 steps of code that you would need to write down. That is going to make your code very messy very quickly. And again, with block-based coding, maybe it'll be a little easier to kind of see where the error is, but imagine that you're writing out those 400 lines of code. If you make an error, that's a lot of code that you have to sift through and kind of figure out where that issue is. So functions are a shortcut. You're going to define a function, and you can see off on the image to the right, we're going to define the function called crack an egg. And then that crack an egg, once we define that function, we'll put those 4 steps in there: get egg, crack egg, open it into the bowl, and remove eggshell. And then every time we want those 4 steps to happen, instead of writing out the 4 steps, we would just call function in our code, and then we would have a side code off to the side where we defined it. So we would call function crack an egg. And you can see that in the image underneath. So when the flag is clicked, let's repeat 1,000 times crack an egg. So we just essentially, if we need to crack 100 eggs, instead of making 400 lines of code, we now just define that function in 2 pieces of code. We made a function, and then our main code goes repeat 100 times call function crack an egg. So in 2 lines of code, we just did what we would have had to do in 400 lines. So you can see it's a super great way to shorten up what you're writing and make your code much more easy to navigate and sift through and review, and kind of just make it nice and neat. So functions, very, very important when it comes to coding. Last concept, something that everyone's familiar with, lists. You make a grocery list, you might have a to-do list, a chores list. A list is essentially just a set of elements. In coding, programs can do all sorts of things with a list. They can add something to a list. So let's say you're playing a video game and you've got 4 characters and then you unlock another one. That video game can then add that 5th character to the list of characters that you're allowed to choose from. You can remove something from a list, or you can just have it read something from the list too. So lists are a little more straightforward. Don't think we need to go into too much detail there, but you can essentially list out all sorts of elements and have your code add something to it, remove something from it, or just call something from that list and bring it into the main source code. All right, I think really quickly, we do have some examples that I want to show you of actual lessons that we're going to go through, but I need to give you some background because they're all based on KOOV. So KOOV is essentially a robotics and coding tool. Like I mentioned, it uses block-based coding as its interface, and that's because it's meant for younger students, ages 8 and up. So really that jumping in point to robotics and coding and design. Students work with a kit that has pieces and then an app where they actually do that kind of code, and the lessons come through the app. So now that you have that background, I'll show you kind of what the palette looks like, and then we'll go through some of those lessons so you can get experience with block-based coding. So first, there are 5 main categories of code in the KOOV coding block. Those are control, motion, sensing, operators, and variable. And in any block-based code editor that you have, they are going to break out the code in different ways. It won't always be like these specific 5, but it'll be based on what task you're trying to complete. So each one of these categories provides different code blocks based on what the programmer is trying to accomplish. So for controls, that's where you can find like your wait seconds blocks, your loops, your if-then statements to make conditionals. Motion, that's where you could get your LED to light up or turn off, or a buzzer to make a noise. Sensing helps a robot kind of establish what's around them so it can bring information into the robot. You can set a timer with sensing. Operators are like your greater than or less than. So you might be able to see in this example, off to the right, we've got like repeat until timer in seconds is greater than 1. So that greater than 1 symbol is your operator, and variables are where you can build your lists out. So dividing code up this way really helps students understand the different segments of what coding can entail. And again, if you're working in like Scratch, you would have different titles for these categories, but the code blocks would still be structured in this same way where, you know, if you want movement, they'd be under this category, or if you wanted to change colors, those would be under this category. So that's how block-based coding kind of works, is it gives you these categories that have different blocks under them that you can select from. And you know each of those code already works because it's already been provided by that specific code editor. All right, let's talk about a lesson example. So for this example, you can see there's 3 different code blocks here. There's a DC motor speed block. That is the specific block that would set the speed of the motor. So essentially you would put a number 0 to 100 in there, and the higher the number, the faster the rotation. So first you need to set the speed. You want the speed to be, you know, we'll just say 50. Next thing you do, the very next block under it, is you need to set the rotation. So do you want this motor to rotate CW clockwise or CCW counterclockwise? And think about it, if you're building a car, if you attach the 2 motors both facing the same way, well, they're both going to rotate clockwise to move it in the same direction. However, if you flip one of the motors the other way, so now they're positioned like this, you would need one to spin clockwise and the other to spin counterclockwise to achieve that same path. So this is that kind of common sense, testing things out. You know, hey, I did this, but it's not working the way I thought, so it's tinkering with it. Then the last code block is your brake or coast. Do you want this motor to shut off completely and bring your object to an immediate halt? Or do you want it to just kind of not continue to power it, but let it coast and let its momentum take it to a stop? So these are the kind of examples and lessons that happen in any kind of block-based coding, where they'll show you the specific block, tell you what it does, and then let you tinker around with it so you can see it in action. And now we'll get into some very specific examples. And I think we've got the chat going, so I'll ask these questions. You can put them in the chat, or you can just think to yourself, and then I'll go ahead and explain at the end. So for example, for this one, does this specific code program make the buzzer go beep, beep? So let's take a look at this code. Well, we have a start block, then we have a buzzer on, and we're gonna wait 0.05 seconds. And then we have a buzzer on, and we're gonna wait 0.05 seconds. So essentially this robot is gonna go beep for 0.5 seconds, but it's gonna stay on. So there is no stop in this one. So for this code, no, that does not make the buzzer go beep, beep. It's just one consecutive beep. Well, how do we go ahead and make it get that stop and that start again? And that's where we look at the code underneath it. So you can see the correct code here. Start buzzer on for a time, so it's going beep, then it turns off and it stays silent for a bit, and then it goes back on for a bit and then back off. So that actually makes it go beep, beep. So you need to have that on and that off, and there needs to be a wait in between the two, because if they're consecutive, code gets read in less than the blink of an eye. So even though that code, you're looking at it and you're like, well, it shows it's off, but there is no wait seconds there, then it's not actually going to stop. And there's going to be an example in this next slide that you can see. So for this one, our first block is start. Then we've got a forever loop. So again, that's our loop. That's what we were talking about earlier when we're talking about loops, and you can make them repeat it once, you can make it repeat it twice, or you can make it repeat forever, which is what a forever loop is. So start, forever loop, LED on, wait 1 second, LED off, and then right back up to the top is LED on. So looking at this on face value, you would say like, oh, that's gonna blink on and off. But again, remember, the progression is gonna go start, forever, then your green LED on, wait, LED off, then immediately back to LED on. So there is no pause between LED off and LED on in this code block. So that robot is essentially going on, wait 1 second, off on. And that off on, there is no gap there. So even though it's reading that code, it doesn't have time. So it's going to go off on again. So even though looking at it, it looks like it's going to blink on and off, when it actually happens, it's going to just stay on the whole time, because the off is so minuscule, such a short period of time that you can't actually see it. So that's where that number 2 goes in. So here you can see the correct code to make it blink. So start, forever loop, on for 1 second, off for 1 second, back to the top, on for 1 second, off for 1 second. So that's the blinking that you're trying to accomplish. And again, this is it's all tinker based, it's all trial and error. You would make that first code and then see, I want it to blink. I'm telling it to go off, but it's not really going off. So what am I doing wrong, or what can I add code-wise to make it so that it does go on and off? Yeah, exactly. All right, let's take a look at another example. So the LED is in port V3, which is just on here, and I'll show an image. This is what a core looks like. These are just the ports that you're referring to in the code. So this code is telling us we have an LED plugged into port V3 and an LED plugged into port V2. So there's 2 LEDs plugged in. First, our forever loop. Then LED V3 is off, and we can see off to the right that the red LED is in V3. So it's saying red LED off, green LED on, wait 5 seconds, repeat 10 times, green LED off, green LED on, green LED off, green LED on. And once it went through that repetition 10 times, then it would move on to the next one. So for the questions, which LED would blink first? Well, which LED has the on switch on first? We see that the red LED shows up first, but it's telling us that it's off. So it's not the red LED, it's the green LED that turns on first. Would both of them blink at the same time? No, they wouldn't, because this code has to get through this repeat 10 times section 10 times before it moves on to the next one. So it's going to have this go 10 times, then the green LED is going to turn off, then it's going to turn on the red LED and blink the red LED. So they're happening separately, not at the same time. Then for the last section, does code segment 1 or 2 make the green LED blink? Well, the green LED we know is in port V2. So let's look at our code and see, okay, where do I see that the LED in V2 is turning on and off? That's up here in this top section, so section number 1. So these are cool little activities that you can be doing. Again, these are obviously KOOV related, but the concepts hold true, and you can make these worksheets on your own to explore these different concepts. Now let's talk about a worksheet for functions. So as you know, a function is a code block that is kind of like a shortcut. A function stands for other code that you've already made. So let's create a function called jump that we're going to use to avoid the obstacles. The arrows show the steps that one would take to jump. So a function to jump, call function jump, it is going to move our little man here up 1, right twice. You can see move up, move right, move down. So function jump is going to go up, right, down. So on this bottom example here, if we want to get our little man from here to the end, using call function jump, what will we do? How would we write that code? Well, we got to start. So we'll say start, then move right to get him into position, call function jump, then it'll run through our jump function. So up, right, down. Then we need to move right again. Then we're going to call function jump again, up, right, down, and then move right again. And we actually need to move right one more time to get to the end. So that's a cool little activity where you can create these little mazes and then set a function, have your student create a function, and you can make it be, okay, let's make our function do up, right, left, and then have them call that function to get to where they need to go. So these are mazes and activities that you can totally build out on your own to teach these concepts to students. Another example of functions, what does the code in box A do? So we've got our call function buzzer 1, call function LED, and call function buzzer 2. So you can see we have 3 different functions built into this, and off to the right you can see where each of them are. So here's our function buzzer 1, here's our function buzzer 2 way off to the right, and then underneath is our function LED. So each time those functions get called, the code would go start, forever, if then statement, then it would come call function buzzer 1, and the code would actually hop over to that function, read through all of that code first, then it would come back to the main code once it was done. Now we're calling function LED, so we're hopping over into the LED function. It reads through all of that, then it comes back into the main code, and then we're calling function buzzer 2 again. So last little question there is functions are used to blank, make code easier to read, to stop the code, or to make the code run faster. A would be the correct answer there. It's to make it easier to read when instructions are repeated. All right, so that is the examples as far as lessons go. Now I'd like to just quick hop over to something else and show you a real life example. So give me 1 second to get this all pulled up again. Share screen. Here's our app. And now everyone should be able to see this. Really quickly, I'll point it out. So I built this earlier, and this is going to be another example of showing what you can do with code. Again, this is a KOOV example, but you can do this with other things too. So we'll continue. So I built this little robot. It's a windmill. I've already coded it. So this is a functioning robot with active code. When I flip the on switch on, you'll see that my windmill starts to turn. So now my windmill is moving, and that's all being done by code. Now, what code are you asking? Well, let's take a look at the code. So this is the code for the windmill. It's pretty easy. There's only 4 blocks of code there. So there's our start. We're going to start, obviously. Our DC motor, there's a motor built into this windmill. That motor is going to spin at a speed of 30. So again, remember 0 to 100, the higher the number, the faster the rotation. So we need to set the speed of the rotation, and then we need to set the direction of the rotation. So speed of 30, and we're going to rotate clockwise for 30 seconds, which you just saw. So this is rotating clockwise for 30 seconds. Now, let's say we want to take this one step further. So we know that this is already rotating for us. Now we want it to rotate the other direction. So we're going to go ahead and to shorten up the example, we're going to make this rotate clockwise for 5 seconds. Then we need to set our next speed. Let's make it spin a little slower. So we did 30 for our first one. Let's do 20 for our next one. And now let's make it spin counterclockwise. So looking at this code, and we need to add a weight to it too. We'll make it spin counterclockwise for 10 seconds out loud. So now looking at this code, reading it from top to bottom, we're going to start. DC motor is going to spin at a speed of 30 clockwise for 5 seconds. Then it's going to spin at a speed of 20 counterclockwise for 10 seconds. So let me go ahead and get this plugged in, and I'll send the new code to this robot so you can see exactly how this new code is being manifested. So we'll go ahead, initialize, sending, and complete. So now this new code is in this robot. So let's unplug it and we'll test it out. So based on my code, clockwise for 5 seconds at a speed of 30, and then I don't know if it lagged out for you, but it switched directions and is now spinning slower for 10 seconds. So that's a coding activity that you can do. And again, this is obviously with KOOV. You can do this with anything you want. And that's essentially how you can do different activities based around block-based coding. I saw a couple questions come in and we're right about at that time. So Kaylin, I'm done as far as my presentation goes. 1 second, just get my share down, and then I'll pass it back to you for Q&A.
Awesome. Thank you so much. I don't know what just happened. My brain just totally went blank. How fun is that? I remember what I was going to say. If you guys have any questions, throw them in the chat. We'll just keep running through them. So first of all, are there any particular projects you would recommend for a first-time coder?
Yeah, so for a first-time coder, again, it all depends on what programs you're using, whether it's Scratch or if you have KOOV. But you should think of it more as task and concept based. So for a first-time project, let's learn what a loop is. So go into whatever program you're working with, whether it's Scratch or KOOV, and just come up with a really, really basic loop. So how would we, let's say the LED for KOOV, again, obviously those are going to be my examples because that's what I'm most familiar with. The LED is usually our first lesson, right? So your goal is for the first 30 minutes is let's code this LED to blink on and off 10 times. So how would you build out a code to make it do that? And some people will go, okay, LED on, off, on, off, and write it out 10 times. And then you would take a look at that code and say, okay, now let's think of a way to shortcut this using one of the concepts that we just discussed. So maybe it's just looping that, or maybe you make a function around that. So when it comes to first lessons, the best thing to do is to pick a concept and really explore that rather than let's try to accomplish a task, if that makes sense.
Absolutely does. And then, you were
Great.
talking about myriad coding languages when we kick this all off. For a beginning coder, is there a particular language that is easier than others?
That is a question I get all the time. It really depends. I am certainly not a coding expert, but I am familiar and I know a few. I would say the most popular coding languages are Python, Java, C, C++, and HTML. Out of those, they all accomplish different things. So it's more of a question of what do you want to do next? Are you interested in finance and numbers? If so, Python's probably where you should go. Are you interested in graphic design or visual elements? If so, then HTML is the way to go. So each of these languages are really tailored to a specific topic or a specific subject. So that's how I would break it down next. If you're still at the age where you're like, hey, I don't know, just give me the next one, I would probably say HTML is probably the way to go.
How young?
And there are books and videos and right. Oh, how young?
How young can a kid be?
For KOOV specifically, I mean, we have kids starting in kindergarten, in first and second grade. So really, I would say, I mean, it's coding when you boil down to it is language. So how young do kids start learning language? I mean, some kids start immediately when they hear, right? But written language, probably right around like 5 or 6 is the earliest I would go. Certainly start with block-based programming, and then as they get into their teens, you can start to get into some of those written code languages.
So we've got a champion in 3rd grade on the chat. Yeah.
Oh, let's go.
Nice. So yeah, you can do it, Alex. You'll be great.
Absolutely, Alex.
And so I'm going to interpret this question, Michael. If it's wrong, please just correct me. He wrote, how would you compare it with Scratch? I'm assuming it is KOOV.
Yeah, I assume he's talking about the code editor in KOOV, and Michael, I think that was what his name was. They're the same, right? So Scratch is a block-based coding language, and KOOV uses a block-based coding language. So under the umbrella of block-based coding, there's Scratch, there's our coding program, but they're all essentially the same thing. So if you're asking how similar, I would say it's the exact same concepts, but the specific blocks of code you get are different.
Great.
Great question, though. And go ahead, Caitlin.
I'm sorry, I'm on a delay. I'm echoing, and so
I noticed there's a bit of a delay.
It's killing
technology.
Me. It's such a champion.
Go ahead with the next question.
Well, unless anybody has anything else to add, I think we've gotten through all of the questions.
Great, and fantastic questions, everyone.
Yeah, I thought this was great. A lot of good.
Me too.
So I do want to give everybody a little note. While we're in the webinar, I did get a message from somebody within our company where our site is temporarily down. So I was going to say you can go to viruskoop.org/Sony. I'm going to tell you to do that via email. Hopefully in the next hour or so, whatever we send out this recording. So it's a temporary glitch, but we'll check back up soon. Great. Nick, thank you so much. We really appreciate your time and expertise today.
Oh, thank you for having me. It was a ton of fun. Great questions. Again, I'm certainly not a coding expert, but it is a lot of fun, and I'm a creative at heart, and it allows creatives to really explore and kind of pursue that part of their personality. So if coding is interesting to you, stick with it. It's only going to open up more doors for you in the future.
Wonderful. And thank you everybody who joined us today. It is always an honor to get to share a little bit of your time. So have a wonderful rest of your day, and we'll see you all soon.
Bye, everyone.